So today we're going to be talking about solving rational equations. And this video is going to contain some examples of different rational equations that you might see, and I'm going to go about solving them. Now, really, when we're solving rational equations, we're really just applying the methods of adding, subtracting, multiplying, and dividing rational expressions. Remember, with rational equations, they're really just more complicated versions of the basic fractions you learned back in elementary and middle school. So, keeping that in mind, let's get started with some examples. Alright, so for our first example, we have 4 over x equal to 1. Alright, and so before we solve this, we need to take note of any areas where this rational equation is undefined. And this rational equation is undefined when x is equal to 0. So x cannot be equal to 0 for this rational equation. So now solving it, we just simply multiply both sides by x, and we get x equals 4. And now to verify that it works, which is what you always have to do with these rational equations, you just sub 4 back into the equation, so 4 over x, so 4 over 4. And from here we can tell that it equals 1. So x equals 4 is the solution to this equation. So now if we go a little bit more advanced, we have 4 over x equal to 6 over x squared. And so now what you can do is, just like with regular fractions, you can cross multiply them. Alright, so that's kind of the solving method for this. But you also just have to keep in mind that there's also a discontinuity at x equals 0, so x cannot be equal 0 because 4 over 0 would be undefined and 6 over 0 would be undefined, right? You can't divide anything by 0. So we just have to keep that in mind when we're finding our solution. So we cross multiply them, and we get 4x squared equals 6x. We can divide both sides by x, and we get 4x equals 6. And then we just divide both sides by 4, and we now know that x is equal to 6/4, which simplifies the 3 halves. Now to verify this result works, you just plug it back into the equation. So 4 over x is equal to 4 over 3 halves, and then that equals 6 over 3 halves squared. And so now what we have is 4 over 3 halves is equal to 6 over 9/4. And so now, just like that, we're just going to divide 4 by 3 halves. And so because of the rules with fractions, we can just say, okay, this equals 8/3, and over here we get 24/9. And does 8/3 equal 24/9? Well, yes. If we simplify this fraction, dividing both by 3, we get 8/3. So the solution, x equals 3 halves, does work. So here's the solution to this particular function. So for my next example here, we're going to be solving the rational equation 4 over x plus 3 equals 6 over x squared plus 1. So the first thing we have to do when we're solving these rational equations is we have to make sure we know where this whole equation is undefined. So on the left side here, the denominator goes to 0 when x is equal to -3. And that's bad because 4 divided by 0 is undefined. So x cannot be equal to -3. If we check the right side here, x squared is always going to be 0 or positive, regardless if you put a negative, positive, or 0 in for x. Because of the fact that we have plus 1 on this side, we know that this term will never equal 0. So 3 is our only area where this whole equation is undefined. So now, keeping that in mind, we can get started. So now, we can just cross multiply, just like regular fractions, and just set 4 times x squared plus 1 equal to 6 times x plus 3. So now what we can do is we can solve this. So we get 4x squared plus 4 equals 6x plus 18. And so now we just combine like terms with like terms. So we get 4x squared, and then we just subtract 6x from both sides, minus 6x equals 14. And so now what we can do is we can divide this whole thing by 2, since all of these terms have a factor of 2, just to make things simpler. So now we get 2x squared minus 3x equals 7. And so now what we can do is we can just use a quadratic formula. So we just bring 7 over to this side too. And voila, now we have a quadratic formula that we can use. A quadratic equation, excuse me. And now we can use the quadratic formula to solve it. So now, a is 2, b is negative 3, and c is negative 7. So now we have negative b, so negative 3, over 2a plus or minus the square root of b squared minus 4 times a times c all over 2a. And so now what we have is 3/4 plus or minus the square root of 9 plus 56 all over 4. So this simplifies down to the square root of 65 over 4. So now, oops, I forgot to add x equals here. So now we know we have two solutions at 3 over 4, and then plus or minus the square root of 65 over 4. And so now we need to check and see if these solutions work in this function. So what you would do is then you would just plug this in. So you would plug in x equals 3/4 plus 65 over 4 into the function and check if it works. And x equals 3/4 minus 65 over 4 into the function and check if it works. And if you just put these values into the calculator and you put this into, so 4 over 3/4 plus the square root of 65 over 4 into here plus 3, and then check and see if the same x value works, if it equals the same thing if you put in this over for x over here, what you'll find is this solution works and this solution works. I'm not going to go prove it to you with algebra because it would just take a lot longer because this is a pretty complicated answer. But I can assure you, I've checked in my calculator right here, that these two answers here work. So these are solutions. So for my final example here, we're going to solve 3x minus 1 over x plus 3 minus 2x over x minus 3 equals 3x squared over x squared minus 9. And so before we get started, we need to find where our discontinuities are, where the whole thing is undefined. And we can see here that in the denominator here, it's undefined when x is equal to negative 3. So x cannot be negative 3. The equation is also undefined when x is equal to 3 for this part here. So that means this whole x cannot be 3. And so we also can see here that x squared cannot equal 9, which means that positive or negative 3 is also out of bounds for x, because otherwise it would send this whole denominator here to 0, which means that this would be undefined. So now what we have is we need to figure out first what this left term is. We need to rewrite this left term as just one rational expression, and then from there we can then see if we can play around with the variables to eventually simplify this down further and involve the right side of this equation. So let's just work with the left side first. So first things first, we need to get a common denominator. So we need to multiply the numerator and denominator by a common factor of x minus 3. And we need to multiply the numerator and the denominator on this side by a common factor of x plus 3, x plus 3. And so we end up with 3x minus 1 times x minus 3 times x plus 3 times x minus 3 minus 2x times x plus 3 over x plus 3 times x minus 3 equals 3x squared over x squared minus 9. And so now what you can see here is that we now have the same denominator. So we can just kind of expand this out. So we have 3x squared minus x minus 9x plus 3. And then this is over x squared minus 9. Hey, this looks nice. And then right here we just have 2x squared plus 6x all over x squared minus 9. Okay, this is looking nicer. And that is equal to 3x squared over x squared minus 9. So now what we can do is we can just multiply this whole thing by x squared minus 9 to get x squared minus 9 out of the denominator. So this cancels out, that cancels out, that cancels out. And we're left with 3x squared minus 10x plus 3 minus, and then this thing is negative because this negative applies to 2x squared plus 6x. So we get negative 2x squared, and then we get minus 6x equals 3x squared. And we can see here that there's a 3x squared on both sides, so these cancel out. And so what we're left with is negative 2x squared minus 16x plus 3 equals 0. So now what we have to do is we have to plug this into the quadratic formula to find our solutions to this rational function right here. So as you can see, we have this solution above, and we boil it down to a quadratic equation. And to find the solution to this quadratic equation, we just use the quadratic formula. So we find that x equals negative b, so this is the negative 16 over 2a, so negative 2 times 2, plus or minus the square root of b squared, so negative 16 squared, minus 4 times a, let me extend this here, times a, negative 2 times c, which is 3, all over 2a, so 2 times negative 2. And so when we solve this, we get positive 16 over negative 4, which means this is negative 4, plus or minus the square root of 256 plus 24 all over negative 4. And so now we get negative 4 plus or minus, and 256 plus 24, well, that is 280 over negative 4. And so really this negative sign on the bottom really doesn't matter, because since we have this positive or negative, if we have a negative, that becomes positive, negative, that's negative. So that goes away. So our two solutions are 4 plus or minus the square root of 280 over 4. And so now We just verify them. And I looked through this ahead of time, and I can verify that these are the two solutions, and you can verify it for yourself by plugging this back into this rational equation here. And so that is your two solutions. So hopefully this helps with your understanding of rational equations. And if you have any questions, feel free to leave a comment below. So thank you for watching this video. Hope it helps.